Okay, this video is going to demonstrate a diagram answer to the question, what processes create a volcanic eruption? So to start with, we're going to draw in our tectonic plates. Draw the Indo-Australian plate in and the Pacific plate. We'll label those. The next thing we can draw in is the North Island, and what you should do when you're doing that is look at the leading edge of the Pacific plate down here, and you want to line up the top of the North Island with that. So we'll just draw in a pretty stylized piece of land. It's not meant to be too realistic, and beside that we can draw in the water. Pacific Ocean here and the Tasman Sea. It's a little bit wonky, never mind. Right, so to answer the question what processes occur to produce a volcanic eruption, we need to show the steps that happen, because the word process, the IGI, important geographic idea, the word process means steps or sequence of events. And the first step in the volcanic eruption is heat from the core. So I'm going to draw number 1, heat from core. And this heat radiates out from the centre of the earth and melts the surrounding rock. It causes the melted rock or magma to circulate and to move, and it moves in convection currents. And these are circular movements that come out from the centre of the earth, rise up to the crust, the magma cools and then sinks back down. So we get a big circular movement of magma. Another convection current over here. And these convection currents, or the movement of magma, causes the tectonic plates that float on top to jostle and bump into each other. The plate movement under New Zealand is called subduction. So number 3 is plate movement. And we have subduction. So subduction means when one plate sinks underneath the other one. This collision with the Pacific plate sinking under the Indo-Australian causes a lot of cracks and weaknesses in the leading edge of the Indo-Australian plate as it crunches into the other one. Okay, next we have with the grinding plate movement associated with subduction, we get a lot of friction on the upper side of the Pacific plate, and at the far end of it we get melting as well. So the grinding of the plates causes the oceanic crust in the Pacific plate to melt, and as it gets plunged into the mantle, the leading edge of the crust melts as well. And because this oceanic crust is lighter than the surrounding magma, as it melts it rises. And so we'll show a big glob of it melting off there, and it finds its way through a weakness in the rock, and usually builds up a big magma chamber as well. As more and more magma rises up to the surface, it collects in this magma chamber here, which can store a lot of magma over hundreds of years or thousands of years. But eventually, step number 5, the pressure becomes too great. And all that magma that's loading the magma chamber eventually leads to an eruption. So number 6 is our eruption. Now in class we learnt a handy mnemonic, which is a way of remembering things. Hello, cool people from planet Earth. So those are our 6 steps. Now, if you produce this diagram in the exam situation, the marker would be pretty happy and you'd most likely get achieved because it shows clear steps that lead from one to another. We've got them numbered in order and we can see how heat from the core leads to convection currents, causes the plate movement or subduction. This friction of the plate causes it to melt, and that finds a weakness in the Indo-Australian plate and leads to an eruption. But if you're after the higher marks, you're going to need to add some specific detail to our case study. So we need to start naming a few things. We've already got the Pacific plate named and the Indo-Australian plate named, but there's a few other things we can name as well. Pacific Ocean, Tasman Sea. And of course we can name our volcano as well, which is Mount Tarawera. We also know some statistics or some quantities associated with this. The heat from the core is estimated to be 6,000 degrees centigrade. The convection currents occur in the asthenosphere. We know we've got this plate movement is called subduction in New Zealand, and that rate of plate movement is 5 centimetres per year. The angle that it's subducting is 30 degrees. And this point here on our diagram, this trench under the sea, is 200 kilometres away from where the volcano comes through. So we can put a bit of a scale on our diagram as well. By the way, this place is called the Hikurangi Trench. Another piece of information we can put on, if we're really tricky, is a bit of a vertical scale as well. So that would be 0 kilometres at the surface. This point here would be 50 kilometres, and the place where the plate is actually melting is 100 kilometres below the surface. So if you produce this diagram, you'd easily get excellence for the question. Good luck.